Hi, all my YouTube viewers. It is Crystal here. I'm here because I wanted to make another video. This is the second video that I have made on this subject. So some of you may have watched the previous video, which I've had to delete because the code in it really wasn't correct. And because the code wasn't correct, I had to delete it. And then I had to research it. At first, it said the census was like 938 million people, and I didn't know how many people were in America, so I Googled it, and it was actually 308 million people. And I thought, well, something's wrong here. And then I thought, okay, well, I'll just delete the duplicate rows. That's probably what the problem is. There's probably a lot of duplicate rows in it. But when I deleted the duplicate rows, it still only reduced it by about 11 million. And I couldn't get the duplicate rows to work anyway because I'm still learning SQL. And so because this data set is in Kaggle, I actually put a comment in the data set asking about duplicate rows, and somebody was kind enough to reply and say that the reason why it gave me 938 million was because it sums the values 3 times. And so I didn't understand why it did that, but I used the code that he gave me to use, and that seemed to fix the problem. So what I'm going to do is I'm going to go ahead and do a code review with this new code. And we got it off of Kaggle data set, the United States Census. I used the 2010 United States Census. So the problem statement was to analyze U.S. Census. And this is what the reply that the guy gave. So I decided to put it in the problem statement. So the data set is set up to report the full population these 3 ways. Zip code total equals total population. Zip code female total plus zip code male total equals total population. Zip code female by age groups and male by age groups equals total population. To get the root data, only pull rows where gender is null and sum them. Oh, well, it would have been nice. I honestly don't know if that was put in the information for the data set, but this guy, Todd, is the one that replied to my query. That's what he said, and he gave me the code to use. So now what we're going to do is, now that we know the problems inherent in this data set, we're going to import the libraries. We're going to import pandas as PD, so that's going to create your data frame. From google.cloud, we're going to import BigQuery and import BQ Helper. From BQ Helper, import BigQuery Helper. And then we say census data equals BQ Helper dot BigQuery Helper. Active project equals BigQuery public data. Dataset name equals Census Bureau USA. And that's the format that you have to use to actually get the data set. We're going to format BigQuery. So client equals BigQuery.client. BQ assistant equals BigQuery helper. BigQuery public data, Census Bureau USA. BQ assistant list tables. So you've got 2 tables, one for 2000 and one for 2010. And I used the 2010 one. We're going to get the schema of the table. BQ assistant head population by zip 2010 num rows is 3. So that's your data frame, and that tells you actually what is in the what is in the data set. And you notice it says zip code and population. It says minimum age none, maximum age none, gender none. So the gender is none as well. So we're going to convert the table to a data frame, and this is actually your schema. This one here is your data frame. And then this is your schema. So BQ Assistant table schema, population by zip 2010. So this is the actual schema. You notice it says gender is nullable. So zip code is required, population, and it's a string. GOID is a string and it's nullable. Population is an integer and it's nullable. Gender is a string and it's nullable. Minimum and maximum ages are integers and they're nullable as well. So now we're going to select the census for one postcode. Now this is a postcode that I lived at a long time ago. I can't even remember exactly which house it was, but I know it was Arkansas. So either I had that postcode or somebody in my family had that postcode. But census equals remarks. Select zip code population as population from BigQuery public data.census bureau USA population by zip 2010, where zip code is 72065. So that may have been my grandmother's zip code. I'm not sure, but it was somebody's zip code. And then what we're going to do is we're going to see how much memory we use to do a dry run. And I did actually use a lot of memory trying to solve this problem. So, I'm trying to select small-ish data sets so I can do more work. But, the more times I run a query, the more data I'm going to use. And then Kaggle only allows me 5 terabytes a month. It says dry run config equals BigQuery dot query job config dry run equals true. Dry run query job equals client dot query census comma job config equals dry run config, and then you print how many bytes it used for the dry run, and it was, I think, 2 million. Let me see. Maybe it was 24 million. It was 439 hundreds, 211 thousands. So maybe it was 24 million, but it's a lot of data, And then so now we're checking census one equals client.query census result to data frame. So these are all the 72065s, and these are all the people living at 72065. And then now what we're going to do, we're going to calculate the population for USA in 2010. Query equals select sum population as population from BigQuery public data.census bureau USA.population by zip 2010, where gender is null. Population equals client.query query.result.to data frame, and then we print the result, and the result is 312,462,997, and that's close to what I googled. Unfortunately, I can't show you what I googled because I'm using a free online video recorder, and because I'm using a free online video recorder, it only allows me to go onto one page. Now, if I had the money to pay for a video recorder, I could look at different pages. And basically, I used to use Xbox on my computer to do that, but the Xbox is all garbly now. Number one, the Xbox is all garbly. And number two, I can't even do a screenshot of myself on my computer because the lens is ajar, and so I would have to take the computer to have it repaired, and I'm a bit hesitant to take it out of the flat because you never know what's going to happen to it if you take it out of the flat. So I'm just going to use this computer as long as I can, and with all of its limitations, and then whenever it just doesn't work anymore, I guess I'll have to get a new computer. So that's it for this video. If you like my video, please like and subscribe, and I look forward to communicating with you in the next code review.